hey, this is not an IoT device, so there are issues. But we'll fix those. So thank you very much for coming over. We are going to talk a lot about Azure IoT Edge and how and what we are doing right now with Edge. There are a bunch of new things that we have added in the last few months. I'm going to go over what those are. And then there's a bunch of demos, 4 or 5 of those. And we know they all work because they're pre-recorded and we brought them here. I'm Arjuman Samuel. I'm part of the Azure IoT engineering team and I lead the Azure IoT Edge engineering. And with me is...
I'm Arpita Dupala. Nice to meet you, everyone.
Okay, and then we are going to tag team here. Let me get this in order. Okay, so a little bit of background here. Almost a year back, we started, a year and a half back, we started hearing these customer requirements where people wanted to understand if they could bring their compute from the cloud all the way to an edge device. And the edge device for that matter was a smaller device, perhaps a gateway class device, but even smaller. And the question was, what can we do to bring AI and machine learning and so on down to the edge? And that Azure IoT Edge is really an answer to that question. We went GA last June, 3-4 months back, but before that we were in private preview for about 6 months. Since then we have had some very interesting scenarios by our customers or partners who have adopted Azure IoT Edge and have started using it right now. Almost many of them are in production. So that's encouraging for us. And then we started thinking about what should we do next and what are the new things that we need to add to Edge. Today we're going to talk about that. So before I do that, a little bit of the background here. We are investing heavily. Microsoft is investing heavily in IoT. Big number there, and that actually translates to tons and tons of new projects, people, and so on, but also enabling a lot of success for our customers and partners. Everything we do is centered around what is required by our partners and customers. The goal, of course, is to enable our customers and partners to either optimize their businesses, so transform it so that they're optimized, create new businesses using connected devices and so on, so they create new businesses, or offer connected devices as a product to their customers. So that's really what we enable. We believe we are simplifying IoT. We believe we are taking the myth out of IoT and making it easier for people to actually start adopting at scale, IoT at scale. So that's really what we are doing here. Now, if you look at how we think about IoT, it's really a combination of the intelligent cloud and the intelligent edge. And these two have to exist together. These two have to be complementary to each other. Intelligent cloud, of course, we have been doing this for many years now with Azure. There's so many resources, services that we have, machine learning, AI, stream analytics, a bunch of different types of storage and so on. So there's a lot of investment we have done to make the cloud intelligent. And with that, without saying, we also are making it more secure, more robust, more reliable, more available, it's spread around the world and so on. So all of that makes our intelligent cloud the most interesting offering out there. And then, of course, now we start looking at the devices out there which are now connecting to the cloud. And these devices, some of them are simply connecting to the cloud and sending data up to the cloud, but many times also need to be more intelligent than that. They need to be in themselves have the ability to do AI, have the ability to do intelligent decisions right there on the device. And so that whole ecosystem of devices, we call that the intelligent edge. The intelligent edge and the intelligent cloud exist together. Intelligent edge gives us the opportunity to be everywhere and be able to deploy all these workloads everywhere. So when we step back and when we think about all the innovation that is happening, we think about it in these waves, these 2 or 3, actually 4 waves that we see that are happening or have been happening. Of course, the first one was cloud about a decade back. We all realized that the one way to actually have cloud, you aggregate data, you bring it all together, you have near infinite resources. And you can do a lot of different things right there. And that also means the organizations can get out of the business of managing their own little deployments. They can use the public cloud. So that's happened. With that, we had IoT deployed out there. So we had a bunch of sensors and devices. We realized they're out there. And we started working on how do you connect them up to the cloud. Bunch of work that we have done, and I'm going to talk about a little bit about the edge, but there's a lot of work that we have done to connect those devices up to the cloud. But then came the realization that once we have the intelligent cloud, we have all these devices, perhaps we should move some workloads onto those intelligent devices. And that is where edge came in. Now, if you think about it, edge is really a stepping stone for the larger deployment of AI workloads. And that takes us to this whole AI workloads being everywhere, being in our environments. Because now the distinction between the cloud and the device is disappearing. They're coming closer to each other. And the devices themselves are becoming more intelligent. And you can actually deploy AI workloads on those devices. So this continuum that we see is it started off with the cloud, went to IoT with devices coming in, edge with intelligence going to those devices. And the reason for doing all that is to create this environment where you can take your AI and deploy it out there. So that's something that we have been seeing. Now, I'm going to talk a little bit about the IoT patterns that we see. First, talk about how cloud plays into those IoT patterns, and then talk about the edge. So we have really three different views or three different buckets in which we put things. The first one, of course, is the things. The things are your devices, your actuators, your sensors, your robotic arms, your what have you, right? Your vehicles and so on, which are connected. Then you have insights. When these things are generating data, you need to know what's going on there. You need to know how to do something on them. So those are insights that we can provide. And for insights, you may use machine learning, AI, and so on. But really, at the end of the day, you want to get some insights about those things. And then you connect those things up and you say, okay, now that I have insights from those, perhaps I can do some actions. Perhaps I could stop that robotic arm. Perhaps I could reconfigure that connected vehicle. And all of those things are now possible. And now you can go back all the way to that thing from the cloud, and you can configure it or stop it or start it and so on. So this whole relationship between things in our environment, insights which are up there in the cloud, and actions which are possible because of insights come together in this pattern. And this is how we look at IoT. Now, add to that the edge. And how do things change when you add edge to this pattern? So let's look at that. Oh, and then, of course, we have our cloud. The main service that we have is IoT Hub, and a bunch of other services next to it, but really that's our key service that enables this. So now let's put edge next to this, and let's see how edge compute transforms this pattern a little bit. You still have the same things which are sending out data up to the cloud for insights. You perhaps have actions. But the interesting part here is that you can move your insights and your actions on that device which is sitting there. Now, this device could be anything, right? This is not the cloud infrastructure. This could be your small little Raspberry Pi 3 type device to all the way to a data box edge type device or a server class device, but they're all sitting on-prem, and they're connected to your other things. So now your things are more intelligent. You can actually do some insights right there. You can do some actions right there. You do not have to go to the cloud. Now, some of the scenarios that are now possible are shown over here. You could have low latency tight control loops. Now that you're not depending on sending all your data up to the cloud, you could actually do things very quickly. Imagine a robotic arm or a lathe machine that needs to be stopped, does not need to go out to the cloud and come back. You can actually stop it right over there, make those decisions right over there. So that's one. You could pre-process data on-prem. Video analytics is one canonical example of that. If you have a bunch of video cameras in this room, and if you're sending all those video streams up to the cloud to look for that one anomalous frame, you are being extremely inefficient, right? Might as well do all the video processing on-prem, preferably on the camera, but on-prem, and then send only that one alert which needs to go out to the cloud. So bringing the compute closer to where it is required. So that's the second one. And of course, intelligence, we've talked about that. How do you bring intelligence on those devices? Protocol translation is another one. Imagine there are Bluetooth, Z-Wave, Zigbee devices also deployed out there. You could do protocol translation on the edge, act on them, and perhaps send it out to the cloud or use it right over there. And then, of course, the last one is important for many of our partners and customers, which is privacy, especially in healthcare and government scenarios. They do not want to send the data out no matter where, right? So they just want to keep it on-prem. And then perhaps anonymize it, perhaps do whatever analysis needs to be done, and only send out an alert or a digest on top of the data. So all of that, these are some of the scenarios that Edge enables. Now on top of it, what we have done now, and we've been doing for some time, all this is possible even when you're not connected, right? When your edge device is configured for those insights and those actions, now you could be disconnected from the cloud, but your edge device behaves as if it is connected. So that's really how we look at the pattern as well as the edge. Do you want to hold on to that question towards the end? We'll have some time for that. Thank you. Okay, so quickly, open, secure, and intelligent. It's important to talk about that because that is something that I'm sure you all will appreciate. I'll go into those details. Open because we have totally open sourced Azure IoT Edge on GitHub. The goal here is that many of our partners and customers require that Edge runtime and everything around it to be adapted to their scenario. And so we have open sourced it in an MIT license, on an MIT license, so you can actually pick it up and commercialize or do whatever with it. So that's one important thing we have done. It's based on Moby. Moby is the underlying engine, container engine for Docker. So we have built everything around Moby. It just works. We provide you all the Moby executables. You put it on the box, and now your device is up and running. I'm going to talk more about the marketplace today because we have some new announcements there. But in order to have an ecosystem of Edge modules, we have created a marketplace where third-party developers can put their modules, and Edge people who are deploying Edge can pick those modules and then deploy it onto those Edge. So I'm actually going to do a demo for that. Security is one of the key things we are working on and we have worked on for Azure IoT Edge. And the reason is because now that you're bringing your compute from the cloud to the edge, if it is not secure, your edge device, there's a lot of opportunity for bad things because now insights and actions are happening there. Lots of that opportunity. So we have built a security model from the ground up based on hardware-based security. There's a lot of work that we have done with our partners, silicon partners and people who put together security hardware. We have done a lot of work with them just so that, one, we provide our customer options. If not this hardware, then this hardware. If not that secure hardware, then this secure hardware. So options, as well as providing the highest possible level of security based on hardware, secure hardware. So we've done that, as well as we allow zero-touch provisioning through our device provisioning service, through which you can actually switch on the device, network it, and power it up, and all of the provisioning and bringing down of configuration happens zero-touch. You do not have to touch the device. We have the security manager, which is what I just described. It's really an API layer to which you can actually have any type of hardware, secure hardware, talk to it, and then upper layers do not have to know about that hardware. Intelligent, we have onboarded a bunch of services. Some are mentioned here: custom vision, machine learning, functions, stream analytics, and so on. We are going to announce a couple more. But more than that, we are going to announce third-party modules which are now available for the edge. And that actually increases this ecosystem. While we provide a lot of value through our services, we also believe that our partners who are third-party developers can provide more value there. And then, of course, all of that backed up with it being totally enterprise-ready. We have deployed, for one, you can actually deploy not just one edge device, but a fleet of edge devices, millions. And the service takes care of their configuration. As edge devices come or go, the configuration updates, and all these devices remain within your compliant configuration. So we have done a lot of work with service-side management of your configuration. You can write your modules. This is the piece of code that runs on your edge device in any language, any of these 5 languages, C, C#, Node, Java, and Python. The whole deployment lifecycle can be managed through VS Code, and as well as a CI/CD pipeline through VSTS. Now, I have a few announcements here where we are actually extending that further, and I'll talk about those quickly. So here are a few, one of the key scenarios we have seen increasingly. Imagine there is these pipelines, hundreds of miles of pipeline, oil perhaps, and they obviously at times leak. They actually can be broken into and so on. So our partner who is actually doing this took a drone, and they actually take a drone and been doing it for some time now, and they would fly this on their pipeline. Typically what they would do is they'll capture all the video, bring that video back, and then start analyzing it offline. And in about a week time, know that there is a leak on that pipeline, which was not really the best thing to do. But now with this IoT Edge, you can deploy it onto your drone. On that drone, you can actually have intelligence. You can have the camera and the intelligence, which is looking for leaks. And it's simply flying. As soon as it detects, it stops, goes over it, and sends out an alert. And all that is possible because now you can run intelligence right there on the drone. You do not have to bring out any video. You only bring out those few frames that are required to detect, that you detected leaks. So that's a scenario we see increasingly. Here is a quick buildup of how that works. There's a camera, IoT Edge device, which is your drone. And then you have connectivity to the cloud. You then have your custom vision code. You have your cognitive services. You have some code which displays and does some segmentation and so on. All of that would be running in the cloud. All you do is you containerize that. You move it to Azure Container Registry. From Azure Container Registry, then in IoT Hub, you create a manifest. That manifest says what are the different modules that need to come to the edge device, the drone, and you move that manifest off to your edge device. This is called the twin. The twin exchange happens, and now the edge device has information about what to move here and from where, and how to stitch that up, how to route messages between them. And then, because now the edge runtime knows exactly what to bring down, the containers, the modules are brought down onto the device, and now you have a fully functional drone which can go out and detect those leaks without having to send data back to the cloud. Okay, so, and then of course you want to update as your drone detects new things, has new data, you want to retrain the models. Simply you go back to your machine learning or AI, you retrain that model, and then you define a new configuration which gets uploaded onto the drone. And then when in the night drone comes back, gets a new configuration. Tomorrow morning it's a new configuration, having more resolution or whatever. Right? So all of that whole management is done through the cloud. Now there are a few things, new things that have happened to that we have been working on, and today we are going to go into more details. We are going to talk about extended offline. Extended offline up till now has been, our offline feature has been, if the device is disconnected for a short time, we queue messages and then it has to come back and it will connect up. But with extended offline, you can actually go offline for months. So we bring all the policies, all the security, all the certificates on the device. Your downstream devices could be connected, disconnected, or in different states, doesn't matter. Your edge is much more intelligent to take them in whenever they arrive. So we're calling it extended offline. You can actually be offline for months and months, and it doesn't matter. The other thing, and I'm going to, by the way, do a quick demo. Third-party modules in the marketplace, I'm going to do a demo for that also. We believe there is a need for our ecosystem of partners to contribute to this whole edge thing. Tooling, we are announcing support for Visual Studio and a bunch of other things, so I'm going to go into detail. I'm sure you know about the Azure Data Box Edge. Quickly, if you want to store a bunch of data on-prem and then move it to the cloud, Data Box is your answer. Tons and tons of terabytes of data. But if you want to actually do some pre-processing on it, then you go for Azure Data Box Edge, which essentially not just stores, but also acts on the data. It can give you an alert before you got all the data to the cloud. So that's a neat scenario where while you're storing data, tons of that, you're also doing some processing on top of it, statistics and so on. Then I'm going to talk about a partnership we have with Intel. The toolkit is called OpenVINO. It makes designing and putting together AI modules for the edge simple. And essentially, you use the hardware acceleration available to all Intel platforms into this one library. Okay, so let's go into the details of extended offline. I gave you a quick overview. Now, the one thing here is your downstream devices can come and go. So you have a downstream devices, you define what those downstream devices are, your edge is sitting there, and then you have a temperature sensor, something else, they're talking to the edge, and they can come and go. Edge now has the capability to authenticate them and apply policies for them. They can also restart. All communication between those devices happens through the edge, so you do not have to be connected to the cloud. So this is one of the key things our partners and customers had been asking for, and here it is. So I'm going to do a quick demo. Well, I'm going to play a video of a demo just to show you how the thing works. I'm going to go over it. I'm going to set things up quickly. Okay, so right now over here we have two devices. One of them on the left is called the button. By the way, they had a few on our booth, but so this is a button which connects to the edge device. It has some basic capability to detect a key press and then can send out a signal to the edge. And on the right here is the MX chip dev toolkit. The dev toolkit has some lights, so when you press the button, some lights glow in different order, right? So essentially there is a scenario where your button can trigger something for the MX chip toolkit, all of that going through the edge. So what we do here is we will connect these two to the edge, and when we do that, and this is what we are doing to just configure the device, the button device to talk to the edge. And once that is done, we move on to defining to IoT Hub, and in IoT Hub we define the relationship between the IoT edge device and the child devices. So here we are. There you go. We have these devices, IoT button and MX chip. We are defining them as children to that edge device, right? And all we need to do is we just need to define that. And all of the underlying policies and auth and certs, because of that relationship, gets transferred to that edge device. And here we are. We pick these two devices up. We add them as the children to this edge device. And this is the local portal that you have on the edge device. And what you see here is these one, and then very soon these two devices, which are now connected to this edge device. And they're sending out data, and they're sending out data to the cloud. So on the left here, message sent to IoT Hub. This is received by the Edge Hub. They are consistent because you're connected. Whatever you're receiving, you're passing on. So that's what the edge is doing. Whatever you're receiving, you're passing on to IoT Hub in the cloud. Now, very soon, what we are going to do is we're going to change the firewall rule just to simulate that the device has gone offline. There you go. I think we changed the firewall rule here. And now the edge device is not connected to the cloud, but the two devices over here are still only connected to the edge. They are sending data to the edge, and as you will now see, the data coming from these two devices is going up. So we are queuing data. Right? We're queuing data, we're holding on to data. We cannot send it up to the cloud because there is no cloud right now. And we do all the interaction between these two. We send, receive data between these two devices. These two devices could be restarted. Whatever you need to do with these two devices would happen. And all that functionality is totally local. It does not need the cloud in any way. And what we are doing here is we are triggering that button so that something would happen over here, and a message is sent back to the MX chip kit. And now, what we'll do is we'll remove the firewall rule, because now we are saying, okay, now you are connected to the cloud. Edge device, you're connected to the cloud. As soon as you connect to the cloud, your edge device, of course, is receiving data, but would quickly start retransmitting data up to the cloud. And it will happen soon, where it will catch up, and you will not have anything left in the queue. And it will take a little time. There you go. It started to catch up, and now your queued messages, which were left on the device, on the edge device, have been synced up to the cloud. So that's really a quick demo. Now, underneath, there's a lot of magic happened. and security demos are anyway hard to show, but the magic was cert exchange and policy application and authorizations for those devices. They were all happening on the edge device, and then all this scenario was made possible. Okay, so that's one. I'm going to move on to the next one, which is our marketplace announcement that we have. We have a bunch of third-party modules now in the marketplace. Solution developers actually now can get modules from the marketplace and create a solution. Publishers, these are these third-party developers, can actually publish and monetize. In the long run, we'll also be able to monetize this. And then they can actually put together these solutions which might have one module coming from Microsoft, another one coming from somewhere else. All this together working as a solution. So that's what this marketplace allows. And it's totally integrated into the flow of how Azure IoT Edge works. So I have a quick demo here. Okay. So the first thing you see in the demo is your edge device. And just to note, I don't think you can see, but edge device here is called Ubuntu 18. It's a Linux box. It's a little device. Ubuntu 18 is the name of the device. And So what this will show here is what is happening on that edge device. And that's key here. And I'll stop at the right place just to show you what all is running. So edge runtime is installed there. Edge runtime is running, but there is no other module, right? So, and over here we'll see that there is no other module. There is just edge runtime running here. And that edge runtime, edge agent right at the bottom is running here. Now what we need to do is we need to go to our favorite search engine. We need to search for marketplace, or if you have the URL to the marketplace, you go there. And you simply look for the module that you want to install here. Now we'll go there, we'll say Azure IoT Edge Marketplace, and you go in there, you navigate to the right place where all the modules are sitting, and I'll show you some of those modules. We go to apps, this is the Azure Marketplace. You go to apps, you go to the Internet of Things, and within that is a new node, which is the Azure IoT Edge modules. There you go, IoT Edge modules. And IoT Edge modules, you'll see all of these. Now, these modules actually are, I'll stop here, from many of our partners. If you look at these, there are a few from Codeit, Aviva, and so on. So there's a bunch of these from Redis also, there's one sitting there, and many of those are first party. You can select you want a partner module or a Microsoft module, it's all up to you. You can select the right module, and from there, I'll just let it run now. There you go, I can go to partner modules, I can go to Microsoft modules, I can pick the right module that I need or want, and I can then get into the flow. There you go. I'm going to pick up the Modbus module here. There's a URL here, but I'll give you that URL later. There you go. We are now going to pick up the Modbus module, and we're going to go through the flow of accepting the license over there. And when I click Get It Now, it will take me to the IoT Hub experience. So in IoT Hub experience, it will ask me what are the devices you want to deploy it on and any other configuration you want to do for it. So there you go. Now this takes you all the way without doing anything to your subscription in Azure, opens that up, brings up your IoT Hub, asks you which subscription, which IoT Hub, and which devices you want to deploy this on, and then simply opens it up for deployment. There you go. And I'm going to pick that IoT Hub demo IoT Hub, and these are my devices. And if you see, Ubuntu 18 is sitting up there, which I am now going to use to deploy this module to. Now, there is a bunch of configuration that is possible. Modbus module has a bunch of configurations, which, for example, what is the IP address of my edge device and so on. I can actually, in the next screen, you will see, I can define all of those if I want. There are some default values there. But after I've done those, right over here, and these are the properties I can change. And from there on, I can simply say, deploy this module. And then I'm going to go back. I'm actually looking for that IP right now to change so that it connects to my IoT edge device. And this is going to change that. There you go. This IP would be my IP address for my edge device, and that's the only configuration I have to change here. And it's a local host, so and then I simply say deploy. And now it started to deploy. Sorry, when I click next here. These are the routes. So when we talk about routes, these are routes where message comes in and where it goes. So I define the routes, and then I say next. And this takes me to my deployment, which I submit. And you'll see over here, up there, you will actually have this deployment going, and your module is now going back to that device, which is a Linux box. There you go. And let's check over here. Right now, there was one module. We look at what other modules have come down, and we will see that we have this module, Modbus, running over here as well. So the whole marketplace experience from discovery to acquisition to deploying onto your edge device is one now. You select either a third-party module or a first-party module. You bring them down onto your edge device without having to go to different experiences, different settings. I need to do this or that, everything part of this experience. So that is how we will have the whole ecosystem going. We'll have third-party and first-party Microsoft contributing to that. Okay, so that's from my side right now. So I'm going to hand over to you, Aprita, and if you can walk us through one of the modules which is also in the marketplace, and we believe there's a lot of value that customers are going to get. Right now it is, yes. But we can go to more questions later on.
Thanks, Arjuman. Hello, everyone. We are excited to announce Azure Blob Storage on IoT Edge, which is now available in public preview, and it's free. I think. Yeah. Blob storage is available in multiple products. Choose what is right for your scenario. If you're looking for blob storage in public cloud, choose Azure. If you're looking for blob storage for large-scale deployment on-prem, choose Azure Stack. If you're looking for blob storage for bulk migration to Azure, choose Azure Data Box. Today, we are announcing Azure Blob Storage on IoT Edge, which you will use when you have a requirement to store, access, and process the data locally. Why use it? Because users can store and access this data using Azure Storage SDK and process this data if required. You can reuse the same business logic written to store and access the data in Azure. You can deploy multiple instances of this module. You can use it on any Azure IoT Edge Tier 1 host operating systems. Azure Blob Storage on IoT Edge is a lightweight Azure consistent module which provides local blob storage. Let's look at an example. We have an Azure IoT Edge device running Azure IoT Edge runtime. It's running a custom module developed using Azure Storage SDK such that it's processing the data collected from the sensor and is storing this data to a local blob store using Azure Blob Storage on IoT Edge module. We support Linux ARM32, Linux AMD64, and Windows AMD64. Here is the list of all the supported and tested platforms. Some of the common workloads include media entertainment, financial data, or any application generating and processing data. And this data that needs to be stored locally or requires local processing is a perfect scenario to use Azure Blob Storage on IoT Edge. And later you can choose whether you want to move this data to Azure or not. We have two simple steps for our developers: deploy our module and start accessing it. To deploy, go to this URL, check out this document, and choose what is convenient for you. Azure Portal, and it's also available in Marketplace as mentioned by Arjun earlier, or Visual Studio Code. In both cases, make sure you're pointing to the Microsoft Container Registry to this module, provide local storage account name, local storage account key, and storage directory. And that's it. One way to access is via a custom module. You can check out this document on how to develop and deploy a custom module. You can use any of the available Azure Storage SDK to develop this module. We have a demo for you, but let's look at this example so everyone understands what we are trying to do in our demo. We have an Azure IoT Edge device, and that will be a Raspberry Pi device. We are running Raspbian Stretch operating system on it, which is running an Azure IoT Edge runtime. We'll deploy our blob storage module such that all the blobs created is dedicated to a single storage account. We'll run a web application custom module developed using Azure Storage SDK such that this web application can be accessed via browser from a desktop. Let's look at our demo. We have our Pi device running Azure IoT Edge runtime. Let's deploy our module via VS Code. Here is the section which I have shown earlier. There it is. So make sure you are pointing to the Microsoft Container Registry URL. Provide local storage account name, local storage account key, and storage directory. Go through the process of deployment. Deployment succeeded. Let's refresh. There's our module. Let's refresh in our portal to make sure. We RDP to our Pi device, and let's list all the modules. There is our module running. Let's list all the modules running in the Pi device, the containers running on the Pi device. So you'll find our module as well as there is a web application running there. Let's try to access this web application from a browser. Let's select a couple of the images to upload. Here, the application is listing all the blobs uploaded. You can delete a blob from here as well. We talked to a lot of customers expressing the need to automatically transfer their raw or processed data to Azure. We are currently working on it. Let's see how it will roughly look like. Go to your blob storage account. In your container, you will find all the blobs from your local storage account is automatically transferred to Azure. They are the same two blobs. That's it for the demo. For more information, check out this document. We'll love to hear from you, so please provide us your feedback. Thank you. Back to Arjun.
Thank you. Okay, so we have a few minutes. I'm going to quickly go over some of the additional things we are doing. Support for tooling is extremely important to enable an easy deployment, first development and then deployment of these modules. So today we are also going into Visual Studio. So if you already use Visual Studio, there is now a plugin which makes Visual Studio totally edge compliant. You can do your coding in C# using Visual Studio. You can manage all the resources, what you just saw in the demo. You can see all the runtime running there. You can go in and see what modules are deployed, all within Visual Studio. We also, CI/CD pipeline is an important element, especially when you're talking about deploying edge in an enterprise. And for that, of course, you have multiple people on the team who are working on parts of the project, and they all need to contribute code or parts of the code together. And so now today we are also announcing support for Jenkins. We believe that's something that the industry has accepted as the pipeline for CI/CD, and we are proud to be there as well. So these are some of the tooling things. we have been announcing. If you haven't seen DataBox Edge in the demo part of the show, please do that. Essentially, there is Edge deployed on it as well. And as I said, you can actually store, but also you can process a bunch of data on the DataBox Edge device. We also have a program which is the Azure IoT certified devices for Edge. Essentially, what we do is we provide a set of requirements to OEMs who are putting together these devices, and then they come out with the right device with the right infrastructure, meaning the hardware, as well as what all needs to be there, including pre-installing IoT Edge runtime on it. And then we certify it. We look at those devices, we certify them, and then we put them onto our device portal. On the device portal, you can actually go in and discover. Right now, there are a few. I think there are about 10 or so devices up there, but many more are coming soon. So the idea is, if you are a customer and you're looking for an Edge device, it shouldn't be rocket science. You simply come here, you pick the device, and you should be assured that this device has the runtime on it. It has been tested to work with Azure IoT Edge. And you simply boot it up, and it should just run. So that's the goal here, and we're working on that. Okay, so the last thing I have here is a partnership that we have with Intel. And this all came about after the realization we had, which is that to deploy AI onto an edge device is hard, especially if you are taking advantage of the hardware acceleration, FPGA, GPU, VPU, CPU. So all those acceleration, if you're taking advantage, typically you would have to write a different driver or some way of accessing those hardware accelerators. With our partnership with Intel and with OpenVINO, which is a toolkit which they provide, you can actually write these computer vision modules in Edge without having to worry about what hardware acceleration you have on an Intel platform. So you simply have that toolkit. Let me play this quickly, and I'll stop and explain as best as I can. So this is happening right now. We are happy to announce this. Let me just set this up a little bit. So acceleration is important. What we now provide here through this work, our partnership with Intel, is a common library which allows you to write your AI, your vision modules without having to worry about what hardware to actually use. It's more efficient because now you don't have to worry about hardware, and your modules are not specific to anyone. You know, this is an FPGA module, this is a GPU module. So you actually just write your module. And then, of course, we have, as part of this work, Intel has put together a bunch of trained models. They're all in Vision, and I actually have a couple of demos on those, which you can actually take, and then you can start playing around with it. It works across these platforms. It's optimized for FPGA, GPUs, CPUs, and VPUs, and so you don't have to worry about that. Let me advance here a little bit and talk about the architecture, which right now should be pretty familiar to you, but I'm just going to bring it up in a minute. There we go. So the square over here is your edge device. You have different types of hardware. You have this OpenVINO toolkit interface sitting up there, which can provide you with all the interfaces. You still manage all your deployments from the cloud in IoT Hub. You manage the manifest, you manage the containers. But then if you have used the toolkit, the OpenVINO toolkit, you don't have to worry about the hardware specifics. And now you deploy, and when you deploy, your models simply are accelerated by whatever hardware you have in there. Actually, we have two examples here. One of them is detecting these cars. Now, the scenario could be any: parking, smart tolling. You know, you have a different toll for electric vehicles versus others, and so on. You could be detecting these vehicles as they're driving in. And right now, with different hardware configurations, you have different latency of that detection. And then you could have multiple of those flowing around. Because of acceleration, it just detects. It would categorize that as car, and then you can use that in yours. So each frame, it will look at that, and it's pretty fast, pretty efficient. Here is a retail scenario where it is counting the number of bottles. You take that out, and this changes on the top. So this is a toolkit. It's already out there. OpenVINO toolkit is, of course, the name of this Intel product. And, of course, it goes on to IoT Edge. You can search for IoT Edge and make it and use it. Thank you, Intel, if you're here. I know we are Thank you for making it happen. Okay, so this is the last slide I had. IoT Edge allows you to deploy Azure cloud services onto these devices, not just Azure, your own code as well. Not just your own code, your modules from third party, you could acquire them and deploy them. You can also do that at scale securely because the infrastructure is built that way. And above all, it's all open, it's all free. Azure IoT Edge is in GitHub, and you can simply get your hands on it and play with it. That brings me to the end. Please do give us feedback for the session so that we can improve. And I'll take any questions that you may have. Question? You're done? Okay. Any other question? Okay, thank you very much for coming over. Thanks a lot.